The scalar product, better known as the dot product of vectors. So if we've got two vectors, so u and v, if I want to find what's called the dot product, it's simply a matter of multiplying the x together, multiplying the y together, and adding them. So the answer is a scalar, because it will be a number. Hence, I guess, why we call it the scalar product. Let's do a quick example. So it's as simple as that. We get the x values, 1 and 6, multiply them together, get the y values, negative 7 and 4, multiply them together, add them, negative 22. So some rules for manipulating with the dot product. If I'm going to multiply the dot product by a scalar, it doesn't matter whether I do that multiplication first or last. So I could multiply, say, vector u by lambda, then do the dot product, or I could do the dot product, then just multiply the answer by lambda. Shouldn't matter. The expanding of parentheses, what you've got to be careful with here is you're not actually multiplying. Now, it's still the same rules as expanding parentheses, but be careful in your setting out. So you don't write it as au, you write it as a dot u, because you're not multiplying the two things together, it's the dot product of the two things. So it becomes a dot u plus a dot v. Now, just like multiplication, you can do it in either order. So u dot v would be the same as v dot u. U dot u becomes interesting, because we're getting the x values, multiplying them together, the y values, multiplying them together, so we end up with the x squared plus the y squared. Well, if you remember our formula for the magnitude, it was the square root of that. So actually, u dot u is just the magnitude of the vector squared. And again, illustrating that it is the same as when we expand parentheses, but a reminder, it's a dot, it's not actually multiplication. So it is like the difference of two squares. We end up with u dot u minus v dot v. And then if we use the idea of the magnitude squared there, we actually do get the difference of two squares. But it's the difference of the two magnitude squares. How is this useful? Well, if I've got two vectors, u and v, I can see how they work with each other. I can find the angle in between and things like that. So I've drawn up a triangle there. So our rule was head minus tail. So the third side of that triangle would be, well, I've called it u minus v. Use the cosine rule. Remember, it's the magnitudes of the vectors, not the vectors themselves, because now we're talking about the length of the side. So the magnitude of u minus v squared would equal the magnitude of u squared plus the magnitude of v squared minus 2 times the magnitude of u times the magnitude of v cosine theta, just our standard cosine rule. Well, if I actually now write that into the x and y's, we can tidy this up. I didn't bother, you'll notice, with the two magnitude u and magnitude v. It's more the other ones because I'm going to get some cancelling there. So on the left-hand side, when I expand out x1 minus x2 squared, I'm going to get an x1 squared and x2 squared, which will cancel with the ones on the right-hand side. Similar with the y's. So I now end up with minus twice the product, x1, x2, minus twice the product, y1, y2, and then on the right-hand side, also minus 2, magnitude of u, magnitude of v, cos theta. Cancelling will now happen. And look what I'm left with on the left-hand side. Well, x1, x2 plus y1, y2, that's the dot product. So I get 2 lots of the dot product is equal to the expression on the right. Divide both sides by 2, and I've got a different formula for the dot product. So if we've got two vectors, there's actually 2 ways we could find the dot product. The first way, probably the quickest way, if you know what the vectors are, is multiply the x values together, multiply the y values together, add them. If you don't know that, but you have the information, you know the lengths of the vectors and the angle between them, then you could use magnitude of u, magnitude of v, cos theta. But note, theta will always turn out to be either an acute angle or an obtuse angle. Because go back to the diagram, what is theta? It ends up being an angle in a triangle. So you couldn't get an answer that's bigger than 180 degrees. So let's find that angle. And this time it's between these two vectors. So I'm going to use that one, that the dot product is the magnitude of A, magnitude of B, cos theta. But I could easily rewrite that and get an expression to find cos theta, which would then allow me to find the angle. So on the top of the fraction is A dot B, multiply the x values together, multiply the y values together, add them, over the length of the vectors. So we'd have the square root of 13, square root of 17. Just a little bit of calculator work, and it turns out to be 48 degrees to the nearest degree. The nice thing about it being cosine, remember the range of the inverse cosine function, it goes between 0 and 180, which is great because these answers are either going to be acute or obtuse, so it will give us the answer straight away. If it's a positive number, we'll get an acute. If it's a negative number, we'll get an obtuse angle. So some other consequences then of our dot product. This one's really useful and we use it a lot. If the dot product ends up being 0, well, think what that means. Now the magnitude of the vectors is not going to be 0, otherwise it would be the 0 vector. Therefore it must be cos theta that's equal to 0. Well, if cos theta is equal to 0, and I could only have answers between 0 and 180, the answer must be 90. Therefore, I know that the vectors are perpendicular to each other. That's very useful. I dot j. Remember, I was the unit vector in the horizontal direction and j was the unit vector in the vertical direction. Well, we know they're perpendicular. Therefore, I dot j must equal 0. Well, j dot I must as well, because it doesn't matter which order we do the dot product in. Now, if it turns out that u dot v is just equal to the magnitudes multiplied together, whether or not it's positive or negative doesn't matter, then what does that mean? It means that those vectors must be parallel, because now we're saying magnitude of u times magnitude of v cos theta is equal to 1. So cos theta is equal to 1. So what's theta? Well, it must be either 0 or 180. Well, either way, they're going to be parallel. How do we tell which direction the vectors are? It comes down to that sign, because we've said plus or minus. So if it's positive, then we know the two vectors are going in the same direction. And if it's negative, then they're going in opposite directions. And the final one there, I dot I, remember I is a unit vector, and j dot j, well, they must equal 1, because we said that I dot I would be the magnitude of I squared. Well, it's the unit vector, so 1 squared is 1. There we go. That'll do us for today.